Hello everyone, today I will briefly introduce the UV visible spectrophotometer and share our experiment using natural dye from Mangosteen Pericarp. First, the UV visible spectrophotometer is an instrument used to measure how much light a sample absorbs. It works with ultraviolet and visible light. When light passes through a solution, some of it is absorbed. The amount absorbed is called absorbance. According to Pericarp law, absorbance is directly proportional to concentration. This means that the higher the concentration of a solution, the higher the absorbance values. Now, I will talk about the objective of the project. The first objective is we extract a natural dye from Mangosteen Pericarp using the solvent extraction method. This gives us a color solution suitable for analysis. The second objective is to measure its absorption spectrum using the UV-based spectrophotometer. We also study the photodegradation plate, which shows how the dye breaks down after exposure to light. This helps us understand the stability of natural dyes and their potential application in food, textile, and environmental studies.
Hi, my name is Pericarp and I'm a Fadli, and my metric number is ASL1524. Okay, first of all, the chemicals and material used include the prepared alpha Mangosteen solution, distilled water, a UV visible spectrophotometer, cuvette, measuring cylinder, Pericarp, rubber, glove and tissue. All solutions were prepared at the required concentration, and all apparatus were cleaned properly before use to ensure accurate result and avoid contamination. Next, the alpha Mangosteen solution was prepared and put into the cuvette. The cuvette was then placed inside the UV visible spectrophotometer to measure its absorbance. The reading were recorded and repeated to ensure accuracy. From the result, we obtained the absorbance values of the pigment and determine its concentration. This experiment helped us understand how pigment absorb light and how UV visible spectrophotometer can be used for analysis. In conclusion, this experiment improved our understanding and pigment analysis and laboratory techniques.
I will be explaining about the procedure for using UVB spectrum. First, the UVB spectrum is switched on and allow it to warm up for about 10 to 15 minutes. This step is very important to stabilize light source before taking any measurements. Next, the sample and the blank solution were prepared. The blank usually contains all the solvent used in the sample, but without the analytes. This is very important for calibration. After that, the cuvette is properly cleaned using distilled water and wipe the outside with tissue paper to remove all the tampering or droplets. Any dirt or smudges can affect the accuracy of the readings. The cuvette is then filled about 3/4 full with blank solution. The blank cuvette is placed into the sample holder in the correct orientations, and the lid is closed. On the instruments, the desired wavelength is selected. The blank or zero button is then pressed to calibrate the instrument. Once calibration is complete, the blank is removed and replaced with the sample solutions in a clean cuvette. The outside of the cuvette is ensured to be cleansed before inserting it into the holder. Finally, the lid is closed and the absorbance value shown on the screen is recorded. If multiple samples are tested, the same steps are repeated for each sample. After completing the measurements, all cuvettes are removed, properly cleaned, and the instruments are switched off. That's the procedure for using a UVB spectrum. Thank you.
Hi, my name is Fitrina Najwa, and now I want to talk about how UV visible works. A UV visible works by passing ultraviolet light from 200 to 400 nanometer and visible lights from 400 to 800 nanometer throughout as a sample, usually in the form of solution. So first we have light source. Light source is the instrument has a special UV and a visible light lamp that produce light for the analysis. Next we have monochromator. Monochromator is the light can produce contains many wavelengths. The instrument selects only one specific wavelength to be used for the analysis. The third part is light passes through the sample in cuvette. The light passes through the solution in the cuvette, and the molecules absorb some of the light as the electrons to move to a higher energy level. The last part is detector. The detector can measure the remaining light after it passes through the sample. If more light is absorbed, then the absorbance is high, and if the less light is absorbed, then the absorbance is low. So based on this process, we can understand how absorbance is related to concentration. Based on Beer-Lambert law, absorbance is directly proportional to concentration. This means that when the concentration of the solution is higher, then there are more molecules in the path of the light. As a result, more light is absorbed, then the value of absorbance it will become higher. So that's why UV visible commonly used to determine the concentration of a substance in a solution.
Okay, Assalamualaikum everyone. My name is Dandarimi bin Muhammad Azwani. My matrix number is A6590. Today I will explain the result of UV visible spectrophotometer. So this is our graph and this is our sample. So this is the result graph after we perform the UV-based analysis on our sample. Based on this graph, as you can see, we are using a natural dye extract derived from Mangosteen Pericarp. The sample was prepared through a meticulous extraction process and subsequently diluted with 2 ml of ethanol to ensure the concentration was suitable for accurate spectrophotometric measurement. For the graph profile, a significant observation is the peak at around 668 nanometers. The specific peak is particularly interesting as it typically indicates the presence of chlorophyll residue remaining in the pericarp. As the wavelength increased beyond this point, the absorbance gradually decreased until it reached about 700 nanometer, which is the upper limit of the visible light spectrum. These overall trends show that Mangosteen Pericarp absorbs more light at lower wavelengths and significantly less at higher wavelengths. This high absorption at lower nanometer is a clear scientific indicator of the presence of concentrated color bioactive compound such as anthocyanins give the mangosteen its deep, unique pigment. Overall, the results successfully confirm that the Mangosteen Pericarp shows strong and measurable absorbance in the visible region, proving its potential as a highly effective and stable natural coloring agent. So, the conclusion for our title is UV visible spectrophotometry is a simple, rapid and reliable analytical technique used to measure the absorption of light in the ultraviolet and UV visible region. It is effective for identifying the presence of chromophoric compounds and studying electronic transition within a sample. The technique provides useful qualitative information and can also be applied for quantitative analysis based on absorbance value. Overall, UV visible spectrophotometry is an important tool in chemical and biological analysis due to its accuracy, sensitivity, and ease of use. So, that's all from our group. Thank you for watching. I hope you guys enjoy the video. Bye bye.